friends, the topic for today is Python modules. Every file of Python source code whose name ends in a .py extension is a module. Other files can access the atoms a module defines by importing that module. This module-based service model turns out to be the core idea behind program architecture in Python. Larger programs usually take the form of multiple module files which import tools from other module files. In today's video, we are going to discuss the role of module from abstract perspective, then Python program architecture, module creation and usage with examples. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon. The topic for today is Python modules. Let us start with brief introduction. In simple terms, every file of Python source code whose name ends in a .py extension is a module. So whatever programs you are writing, where you may define function or any other thing, but if it has the .py extension, then it is a module. So other files can access the atoms a module defines by importing that module. So you can access the functions written in a module just by importing that module. So this module based model is the core idea behind program architecture in Python. We are going to discuss the program architecture in Python in details. So larger program usually takes the form of multiple modules files which imports tools from other module files. So one of the module is designed as a main or top level file, and this is the one launched to start the entire program. So in short, modules provide an easy way to organize components into a system by service as a self-contained package of variables known as namespace. So all the names defined at the top of the module file becomes attributes of the imported module object. Thus, you can create a large project by say importing modules, different modules. Then let us first understand the role of module from abstract perspective, because that will give you why we need the module. That will give you an idea about that, and then only you will be able to understand module fully. So first role of module is code reuse. See, when you are writing or typing the code on the Python interactive prompt, code say it will go away, but whatever you code in a module file, it is persistent or it will remain as it is because you are saving the file with .py extension. So it can be reloaded and rerun as many times as needed. So modules are the place to define names known as attributes, so which may be referenced by multiple external clients. So you can import the different things which are defined in the module from the external client. Then the second role is system namespace partitioning. See, modules are the highest level program organization unit in Python. They are just package of names. So modules seal up names into self-contained packages which help to avoid name clashes. So you can never see a name in the another file unless you explicitly import that file. So when you want to use any module, we'll have to first import it, and when you import it, then only you will see the names in that file. So in fact, everything lives in a module. Code you execute and objects you create are always implicitly enclosed in modules. That's why the module is very important in Python. Then the third role of module is implementing shared services or data. Say, from operational perspective, if you look at it, modules also come in handy for implementing components that are shared across a system and hence require only a single copy. So that means when you are writing modules and the components we are writing in a module, they can be, say, imported anywhere across the system. So they can be shared across the system. So we need only a single copy of that. We need not rewrite anything. So that is how we can use the modules for shared service or data. Then coming to the Python program architecture. So generally, when we look at a Python program, it will consist of multiple text files containing Python statements. So this program structure, we call it as one main top level file along with, say, 0 or more supplemental files known as modules. So that will be the general program structure. So top level files containing the main flow of the control of your program. This is the file you run to launch your application. And the module files are libraries of tools used to collect component used by top level file. So that's why the top level files use tools defined in module files and modules use tools defined in other modules. So in this way, the different definitions will be used for program. So module files generally don't do anything when run directly. Rather than they define tools intended for use in other files. That is the main role of module. So in Python, file imports a module to gain access to the tools it defines. So whatever tools we have defined, if you want to access those tools, then we make use of the module. And for that, we'll have to import the module. So here, these things which we import, they are known as the attribute. Variable names attached to objects, they are called as the attributes. So generally the functions have the attribute. Then lastly, we import modules and access their attributes to use their. So this is what you have to understand. We write the different modules with some functions and then we import them with the help of attributes to use their tools. So let us take a look at the structure of a Python program. So here the structure of Python program is composed of 3 files: a.py, b.py and c.py. So the a.py, this is the top level module. Here b.py and c.py, these are the modules. They are simple text files of statements, but they are not usually launched directly. Instead, uh, the modules are normally imported by other files that wish to use the tools they define. So that is the main idea in Python. And then here you see the standard library module. So these are the modules provided by Python itself and are not files you will code, but you can use them. So Python automatically comes with a large collection of utility modules known as the standard library. And then when you want to use the different modules in the standard library, you can just import them and use it. For example, you want some mathematical functions, then you can import the maths module from standard library. Then let us see how to create module creation. Define a module. Use your text editor to type some Python code into a text file and save it with a .py. So that is the extension, Python extension, and such file is automatically considered as a Python module. So whatever you save as with .py extension, that will become a Python module. So all the names assigned to the top level of the module becomes its attribute. So, and they are exported for the clients to use. Okay, here you take example. Here we define this printer function. So, and we are passing x that. So this is the module attribute, and then this is the body. It will print the whatever we are passing it as a argument. So if you type the following definition into a file called module1.py, then and import it. So if you create module object with one attribute, that is the printer, which happens to be the reference to the function object. So this is the attribute printer. So you will be able to import this. Let us see how we can do it. So module usage. Module can use the simple module file, just whatever we have written, by running an import or from statement. So both statements find, compile and run a module file's code, and if it has not been loaded, so that will be compiled and run. If it is not loaded, it will be done. So the first statement we use for importing is the import statement. So now already we have defined one module1. So when you give this statement import module1, so we can get the module as a whole with this statement. And then when you want to access the attribute, so module1 dot printer, so you are able to access the attribute. So, and here we are passing this hello world, this string to the printer. So when we pass this, we'll get the hello world print. This is the output. So because import gives a name that refers to the whole module object, so we must go through the module name to fetch its attributes. So here for fetching the attribute, we'll have to say right here module1 dot printer. Then only we are able to fetch this printer attribute of module1. So The main difference is that import fetches module as a whole. So you must qualify to fetch its name, in contrast from the fetch or copy specified, that is specific name of the. So next we take the from statement. So here when we use the from statement, we will also copies the names from one file over another scope, but it allows the use of copied names directly in the script without going through the module. Say here when we say from module 1 import printer, so we have imported this attribute printer from module 1, and the copy is available. Copy out one variable. So that is what we have done. And when we want to use it directly, you can say printer hello world. So here there is no need to again put the module 1 name, because we have already done it here from module. So this will give us the output hello world. So this has the same effect as the prior example. Previously whatever we have done with the import, but because the imported name is copied into the scope where the from statement appears, using that name in the script requires less typing. So here we need not type module 1, so we can directly use instead of naming the enclosing module. That is what is the basic difference. Then let us go to the next, the from star statement. So it uses a special form. So when we use a star, we get copies of all names assigned at the top level of the reference. So again we can then use the copied name printer in our script without going through the module name. So again when we say from module 1 import star, so here copy out all variables. Since module 1 has only one variable, only that will be copied. But if a module has any different variables, then in that case we can import all of them with the from import state, import star. So once we have imported it, then without giving the name of the module, we can use it to printer hello world. So again it will print the. So these are the three ways of importing the modules attributes from the module. Then the last part is the standard library module. The modules that are pre-installed in Python are together known as the standard library, and there are many useful modules in the standard library. Like we have the string, date, time, math for the mathematical functions, and date and time for the local time or the date we can get. Then random, then OS, that is for the operating system, then sys, then socket, multiprocessing, subprocess, then doc test, unit test. These are generally used for the testing and debugging, arc parse, etc. So these are some of the useful modules in Python. Then we'll take some examples on modules. The first is date and time. So here we'll import the module time with import time, and then we have variable local time, so we'll make use of the attributes of time. So time ASC time, and here we're putting time dot local time, then again time dot time. So that will give us the local current time, and it will be printed. Let us see how we can execute this. So let us open the Python ideally, and here I have already edited the program. So import time, and then we have taken the variable local time, which is given the print statement. So it will print the current local time. Let us run the program. When you press the run module, it will run, and here you can see the local current time is here. It will give the Monday, December 30. Then this is the time 21:32:01, and this is the year 2019. Then the second example we are going to take is value of pi. So here we'll take from math import pi. But we are importing this from the math module, that is, which is the standard library, and then we can just print pi equal to plus pi. So again, let us see what result we get with this. Now here is the program for value of pi. So from maths we are importing this pi, and then we can directly print it with the print statement. So we'll run the program, run. So you can see here we'll get the value of pi 3.141592 and so on. Then with this we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon if you want to get notifications about our future videos. Then thanks for watching. Have a nice day.